7 visitors from the edge of the void are hurtling towards our sun. While that sounds like the opening of a sci-fi blockbuster, it's actually a snapshot of the constant traffic passing through our cosmic neighborhood. In late 2024 and into 2025, a lineup of comets is set to light up our skies, including one that astronomers are whispering could be the comet of the century. Is this just a spectacular coincidence? Or is our ability to scan the cosmos revealing a sky far more active than we ever imagined? Let's explore this together. The digital sky watchers. Have you ever wondered who finds these cosmic travelers? Every night, a silent network of digital eyes sweeps the heavens. These are the world's automated comet hunters, primarily the Pan-STARRS project in Hawaii and the Atlas survey, a NASA-funded project with telescopes in Hawaii, Chile, and South Africa. Led by principal investigator Dr. Larry Deneau, the Atlas system is designed to scan the entire sky every 24 hours to identify moving objects. Their cameras are incredibly sensitive, able to spot objects down to magnitude 21, which is over 100,000 times fainter than the faintest star you can see with your naked eye. The Pan-STARRS PS-1 camera is a 1.4 gigapixel behemoth, capturing several terabytes of data each night. The real prize isn't a static picture but movement. Sophisticated software compares new images against a vast digital map of the cosmos, flagging any pixel that is shifted. Once a candidate is flagged, an alert is sent to the Minor Planet Center, where Dr. Matthew Holman and his team process the data, triggering follow-up observations from around the globe. They are joined by other powerful surveys like the Zwicky Transient Facility in California, creating a planetary defense network of unprecedented capability. The entire process from initial detection to confirmation can happen in less than an hour. This digital vigilance has completely transformed the field, turning comet discovery from a waiting game into a real-time hunt. 7 against the odds. So, what are the chances of seeing a truly spectacular comet? Astronomers joke that the universe is stingy. The models that predict comet populations, like those from Dr. Harold Levison, show that the confluence of a perfect orbit and a large, active nucleus is incredibly rare. Most great comets are first-time visitors from the Oort cloud, a theoretical sphere of trillions of icy bodies named after Jan Oort, stretching an immense 100,000 astronomical units from our sun. For every comet Hale-Bopp, with its 60-kilometer nucleus, there's a comet Kohu-Tek from 1973. Hyped as the comet of the century, it fizzled dramatically, teaching astronomers a hard lesson about the unpredictability of these icy bodies. As the legendary comet hunter David Levy once noted, comets are like cats. They have tails and they do precisely what they want. Statistical analyses suggest a Hale-Bopp class event occurs perhaps once every few centuries. The odds for a bright naked-eye comet are better, maybe one every 5 to 10 years, but many of those are poorly positioned for viewing. This is what makes the buzz around C/2023A3 so palpable. It's a genuine contender that could defy the odds. The quiet visitors. Not every comet is a headline grabber. Some slip through the solar system as faint smudges, their passage noted only by dedicated observers. Among the 7 visitors of 2025, 2 fall into this quiet category, C/2022E3 or Pan-STARRS, and the periodic comet 240P/NEAT. C/2022E3 reaches its perihelion on July 31st, at a chilly distance of 3.82 astronomical units, or about 571 million kilometers from the Sun. At that range, it's not expected to brighten beyond a modest magnitude 10, visible only in medium-sized telescopes. Then there's 240P/NEAT, which was discovered in 2002 and returns every 7.6 years. It makes its pass on December 19th at a distance of 2.12 astronomical units, or 317 million kilometers. Its performance will likely be even dimmer, a low-key encore for those tracking its well-documented path. For both of these objects, the primary audience will be astronomers contributing data to the Minor Planet Center, where every verified observation helps refine orbital calculations. Even these faint comets provide crucial data on things like nucleus rotation and the slow development of their comas. They are the workhorses of cometary science, providing a baseline of normal activity against which the brighter comets can be compared. The crowd pleasers. Every now and then, a comet arrives that's, well, destined for the spotlight. Back in 2020, it was Comet Neowise, with its 5-kilometer nucleus. But now, all eyes are on C 2023 A3 Tsuchinshan Atlas. Discovered on January 9, 2023, it's on an 80,000-year orbit that will take it to a perihelion of 0.39 astronomical units. Forecast models by Dr. Quanzi Ye suggest it could reach a magnitude of 0 or even brighter, thanks to some powerful forward scattering of sunlight. For a bit of context, another great comet, Hyakutake in 1996, passed a mere 15 million kilometers from Earth, revealing a stunningly long ion tail that stretched over 100 degrees across the sky. Now, while Tsuchinshan Atlas won't pass quite that close to Earth, its intrinsic activity could be very high, with some estimates suggesting a dust production rate of thousands of kilograms per second near the Sun. If it manages to hold together through the intense solar heating, a major uncertainty for any first-time visitor, it could develop a brilliant tail visible even from light-polluted cities, becoming a true generational celestial event that inspires millions to look up. Spacecraft Symphony. So, what happens when a comet is hiding in the Sun's glare? Well, some of the 2025 visitors like 414P Stereo will be almost impossible for us to see, but they'll be front and center for a fleet of solar spacecraft. On September 27th, 414P reached perihelion at just 0.504 astronomical units, or about 75 million kilometers from the Sun. From our perspective, it'll be lost in the bright sunlight. This is where missions like SOHO and Stereo and experts like Dr. Carl Badams of the Naval Research Laboratory come in. Their coronagraphs, like SOHO's LASCO instrument, are designed to block the sun's direct light to monitor solar storms, which gives them a perfect view of sun-grazing comets. These instruments can reveal details about their activity that ground-based observers, well, just completely miss. In addition to images, spacecraft like the Parker Solar Probe and Solar Orbiter could use their plasma detectors to directly sample the material in a comet's tail if their orbits happen to align. This would provide an in-situ measurement of the tail's composition and its interaction with the solar wind, which travels at speeds over 400 kilometers per second. These missions really offer a completely different perspective, turning the entire inner solar system into a coordinated laboratory. The 6-month marathon. The arrival of a great comet isn't just a single night's event, it's really more of a marathon. For C 2023 A3, the show unfolds over months. For most of early 2024 it was a faint target, brightening from magnitude +12 to +10. But the real action begins around its September 27, 2024 perihelion, the so-called danger zone where tidal forces and thermal stress are at their peak. Its closest approach to Earth comes around October 12, 2024, at a distance of about 71 million kilometers. Throughout this journey, thousands of observations from amateurs provide a continuous light curve, basically a plot of its brightness over time. This data, often compiled by organizations like the Association of Lunar and Planetary Observers, or ALPO, is crucial for spotting sudden outbursts or signs of fading. Citizen scientists like Terry Lovejoy, who has discovered 6 comets, play a vital role in this global effort. The compressed schedule really turns the sky into a living laboratory, a story that unfolds night after night, with data from around the world painting a complete picture of the comet's behavior. Tales of two tails. So, why do comets have tails, and why do they sometimes have two? The answer goes back to the 1950s when German astrophysicist Ludwig Biermann first proposed the existence of a continuous solar wind. And well, he was right. Every comet grows at least one tail, and often two as it nears the Sun. The dust tail is broad, curved and pale, made up of silicate and carbonaceous dust grains that are pushed away by sunlight. This tail can stretch for over 10 million kilometers, with its particles moving at a relatively leisurely pace of a few hundred meters per second. The ion tail, on the other hand, is a straight, narrow blade of electric blue, formed when the solar wind ionizes gas molecules like carbon monoxide. The solar wind then grabs these ions and hurls them away from the Sun at hundreds of kilometers per second, creating a tail that can exceed 100 million kilometers in length. The blue color comes from fluorescence, mainly from ionized carbon monoxide, or CO+. And, if the geometry is just right, observers on Earth might even spot an anti-tail, where dust in the comet's orbital plane appears to point toward the Sun. These two distinct tails offer a direct, large-scale visualization of the invisible forces shaping our solar system. when solar storms strike. A comet's tail isn't just a passive trail, it's actually a battleground. The sun sometimes unleashes a coronal mass ejection, or CME, which is, well, a billion-ton cloud of plasma. On April 20, 2007, Stereo A watched a CME slam into Comet Encke. As analyzed by heliophysicists like Dr. Angelos Vourlides, the footage showed the comet's ion tail being sliced clean off by magnetic reconnection. This happens when the CME's magnetic field lines snap and explosively reconnect, releasing immense energy. A fast CME can travel from the Sun to Earth's orbit in as little as 15 hours, moving at over 2,000 kilometers per second. And you know, this isn't rare. Comet C2011L4, or Pan-STARRS, also experienced a dramatic disconnection in 2013. These events provide a unique, large-scale plasma laboratory, allowing scientists to witness physics impossible to replicate on Earth. Seeing a tail disconnect is a visual proxy for a plasma cloud that could later impact our planet, providing a beautiful, if a bit ominous, early warning of potential geomagnetic storms. The interstellar outlier. So what happens when a visitor from another star system drops by? Nothing in the 2025 lineup is as scientifically valuable as 3I Atlas. It follows in the footsteps of 1I Oumuamua and 2I Borisov, which gave scientists like Dr. Karen Meech our very first chance to study material from other star systems. Early observations of 3I Atlas from the James Webb Space Telescope are already, honestly, staggering. The coma, its glowing envelope of gas and dust, has been measured at nearly 700,000 kilometers across, half the diameter of the Sun. The nucleus is ejecting fine dust at a rate of 6 kilograms per second. What's truly shocking is its chemistry. Spectroscopic analysis reveals an 8-to-1 ratio of carbon dioxide to water, a composition unheard of in solar system comets. This implies 3I Atlas formed in a region of its home star system that was far colder than our own Kuiper belt, below the CO2 frost line. The most tantalizing possibility, however, is that simulations show its dust trail may cross Earth's orbit in mid-2026. This could create the first-ever meteor shower of interstellar material, allowing us to capture and analyze dust from another star as it burns up in our atmosphere. Windows to wonder. So, how can you see the next great comet for yourself? For C2023, A3 Tsuchinshan Atlas, the key dates are in late 2024. The best viewing window is predicted to be from roughly October 12th to the 20th. It will appear in the evening sky, visible in the west about 60 to 90 minutes after sunset. Use an app like Stellarium to pinpoint its location as it moves from Virgo towards Serpens Caput. Give your eyes at least 15 minutes to adjust, and try using averted vision. That means looking slightly to the side of the comet. This uses the more light-sensitive rod cells in your peripheral vision, making faint objects appear brighter. For those wanting to take a picture, a DSLR camera on a tripod is really all you need. Using a standard lens, try an exposure of 10 to 15 seconds at an ISO of 1600 or 3200 to capture both the comet and the background stars. As veteran observer Johnny Bortle would advise, brightness predictions are notoriously difficult. The goal is to go out and look, regardless of the final outcome, to witness a rare and beautiful cosmic event. The Great Comet Parade of 2025 is more than just a rare celestial alignment. It's a profound reminder of the dynamic, ever-changing universe we inhabit. From quiet, distant travelers to brilliant crowd pleasers, and even a visitor from another star system, this event offers something for everyone. It's an unprecedented opportunity for scientists to study these icy relics in real time, and for all of us to connect with the cosmos on a personal level. So, get your binoculars ready, mark your calendars, and prepare to be amazed. This is a sky show you won't want to miss. Don't forget to like, subscribe, and hit the bell icon for more updates on this cosmic event. Thank you for watching Simply Science.